Alright, for our next standard that we're going to look at is we need to be able to predict weather conditions and patterns based on the information from weather data collected from direct observations and measurement, wind speed and direction, air temperature, humidity, and air pressure, weather maps, satellite and radar, cloud shapes and types associated with elevation. So that's a whole lot of stuff there. Now this is a bit of a review from another day, from another standard, but they've stated it again, so I want to. Climate is defined by the average temperature, precipitation, humidity, air pressure, and wind, all over time in one particular space. Weather forecasting is actually accurate predictions of future weather. Accuracy is dependent on technology advances, and weather maps are useful to predict weather. So here's just a beautiful weather map that I drew for you. Well, maybe not that beautiful, but you need to draw this. And I have basically the United States, Canada, and Mexico. And some of the things you always find on a weather map are cold fronts and warm fronts. They're typically a blue line. Precipitation, here I have a little rain over here on the west coast. Wind direction, and wind generally comes from that direction. Not always, but generally. You also have cloud cover up here over my mom and dad's house. The temperature here is about 80 degrees, it looks like, in North Carolina. And stationary or occluded fronts that you would have by other lines, and then areas of high or low pressure. Now, weather systems in the United States generally come from the west coast to the east coast. Not always, but generally. It also tends to go north, from south to north. Alright, now, technology like computers and satellites and radar obviously help forecasters. In fact, here I have my iPad, and I have this really neat little app I like. I think it's called Weather Magic or something like that. First thing it comes up and tells me there are weather alerts. There's weather alerts for a couple places. Boston, it's nighttime, it's 8:45 in the evening. It tells you the temperature and tells you all kinds of things in forecast. When I switch over to Hickory, it's 49 degrees, and you can see it's a clear sky. Mapleton, which is where my mom and dad are, it's also 43, 49. It's almost the same as here. In Minot, North Dakota, which is where my stepson is, look, it's still not dark outside. It's 30 degrees there, and it looks like they could get snow on Wednesday. Or Hagen, Germany, where my friend Andreas is, and it's 2:46 in the morning and 52 degrees. And that's just one of, and Blowing Rock is 45. I think that's, and Pittsfield, that's where Anna's going to go to school next year, tells you all these different places what the temperature would be. That's kind of cool. The technology is amazing and super simple on something like this. Now, forecasters don't necessarily use that kind of weather magic, kind of an app like I have, but they could. But when they're doing that, wind speed is measured by observing what the wind actually does to other objects. Here we have a windsock blowing out to the side. That's a very traditional way to measure wind speed. Or actually, you could have an anemometer that would do that. Temperature is measured by the energy in the air molecules. Where does the energy come from? The sun. Relative humidity is something we know an awful lot about here in North Carolina. It gets very, very humid. Actually, relative humidity compares the actual amount of water vapor in the air compared to the maximum amount of water it could hold. And we know that on those super humid days, it's hard even to breathe. There's so much moisture in the air. On the drier days, your hair ends up all staticky. So those things are kind of important to know. And you know about them from experience. Now, another thing that weather forecasters do is they look at cloud types. There are three basic kinds: cirrus clouds, stratus clouds, and cumulus clouds. Cirrus clouds are high-level clouds, and due to the high altitude, generally have ice crystals in them. Let me see. Stratus clouds and cumulus clouds are low-level clouds. Stratus clouds are layered clouds that bring on a drizzle and widespread rain. Cumulus clouds are low-level clouds that really are just there. They don't do a whole lot right away. Now, cooler air, we know, is more dense and it sinks below the warm air. The leading edge of the cold air is called a cold front. It's represented by a blue line on a weather map, and it often has triangles. It tends to move twice as fast as warm fronts. Now, warm fronts are the leading edge of a warm air mass. They're usually represented by a red line with semicircles. All of that is wonderful information to have, but I'm giving you an assignment. Here it is. You need to find a weather map and draw it in your notebook. I want you to label as many things as possible that I've told you what they are. Try to do them in color and try to be as detailed as possible. Got it? Great.